Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Hi everyone. So this is a video about 1.4 charge in a uniform electric field, where in this subtopic, okay, you need to explain quantitatively with the aid of diagram the motion of a charge in a uniform electric field, and then use equation E equals to V over D for uniform electric field. And we have 4 cases for the charge in a uniform electric field. We will go through all the 4 cases after this one by one.
Okay, first we're going to look at the relation between V and E. So from the diagram, we have two parallel plates where it have a potential difference V, and inside the two parallel plates there is a uniform electric field E. Okay, so the relation is E equals to V over D, where E is the electric field strength, V is the potential difference between two plates, and D is the distance between two plates. The unit is volt per meter, and it is a vector quantity for E, and the direction for E is towards the negative plate.
Alright, now look at example 1.4.1. We have two parallel plates with voltage 50 volt. The separation distance between them is 0.05 meter. Calculate the electric field strength between them. So we need to find E. What is the equation that we have learned before this? Yes, it is E equals to V over D. So substitute the value 50 divided by 0.05 and we will get 1000 volt per meter. Okay.
Alright class, so let's try this 3 exercise. Please do it yourself, okay? You can check whether you really understand for the first subtopic, okay? Okay, so have you tried? Okay, good. Okay, now we will look at the overview for the 4 cases that we are going to learn. So how the charge move in the uniform electric field? The first case is, it is stationary charge. That means the charge is not moving. So what happened to the charge? And for the second one, it is moving perpendicularly into the uniform electric field. So the motion for the charge will be parabolic motion. And for the third one, it is moving parallel in a uniform electric field. And the last one, case 4, just like case 1, it is moving with constant velocity. Alright, now we look at case 1 and case 4. For these two cases, we can combine it together because both cases are zero acceleration. As you can see from the diagram, when the electron or proton stay inside the uniform electric field and it is not moving, the forces that we have is Fe. Fe stands for electrostatic force or Coulomb force. Okay, this is due to the unlike charges. Okay, it will have an electric force, and one more force is weight. Okay, the weight will be downwards. So since F is equals to 0, summation of F equals to 0, so that Fe will be equals to W.
Okay, let's try example 1.4.2. As shown in figure below, a charged particle remains stationary between two horizontal charge plates. The plate separation is 2 cm and mass of the particle is 4 times 10 power of negative 13 kg, where Q is equals to 2.4 times 10 power of negative 18 coulomb. Find the potential difference between the plates. So list out the information. We have D, M and Q. We need to find V. So as we know, this is a stationary charge. So for stationary charge, summation of F equals to 0. So Fe is equals to W. So we can substitute Fe with QE, W with mg, and then take V as a subject and substitute all the values, where m is 4 times 10 power of negative 13, g 9.81, and then d 0.02, and Q 2.4 times 10 power of negative 18. So we get 32.7 times 10 power of 3 volt for potential difference. Okay, look at case 2. The charge moving perpendicularly to the field.
We have two parallel plates. The first one is negative. Okay, the second one filled with the positive charge. So the direction of electric field will be upwards, okay, towards the negative plate. So what if we have an electron here? So what happened to the electron after it entering the uniform electric field? So as you can see, it will moving with a parabolic motion. Okay, why? Okay, this is due to the Fe, electrostatic force. So from the top view, okay, let's say the electron in the middle of uniform electric field, we only have Fe. Okay, this is from the top view. So from summation of Fy, okay, we know it is equals to Ma, and Fy is equals to Q naught E. So we will get that Ay equals to Q naught E over M. So how about the velocity? So we can find the velocity at the end of the plate by using the equation of magnitude V, where it is equals to Vx squared plus 2Vy squared, and then we set the value. Since we can see that Vx and Vy, we have Vx and Vy, so we can find the direction by using tangent theta equals to Vy over Vx.
Okay guys, so we know that the path of the electron in the uniform electric field is a parabolic motion. So when we have parabolic motion, we need to apply the resolving, the resolving vector for V, U, A and S. Please do not remember or hafal the formula for Vx, Vy and so on. Okay, you just look at the diagram and remember what we have learned in chapter 2 for semester 1. Okay, as you can see from the electron, okay, it is moving with V naught. So the electron is moving horizontally. That's mean our Uy is 0. Okay, how about the motion? The motion is parabolic. It is moving horizontally. So the acceleration for x-axis is 0. And for y-axis, for this electron or for this charge, okay, in a uniform electric field, A is equals to QE over M. You need to apply A equals to QE over M for y-axis only, since AY for AX is 0. Okay, so we have Vuat Sutat, and then we just substitute into the equation. If we need to find Vy, then we use Vy equals to Uy plus 80, and then we can cancel our Uy with 0. Other than Vuat, we also can use Vuas. Alright, so please just understand the diagram and apply. Okay. Now we will look at example 1.4.3.
Okay, so for this question, we have electron travelling with speed 1.5 times 10 power of 7 meter per second enters the space between two parallel metal plates with 60 millimeter long. The electric field between the plates is 4 times 10 power of 3 volt per meter. So the first question is we need to sketch the path of electron in between the plates. So firstly, you need to know where is the direction of the electric field. Okay, remember direction of electric field is downwards. Why? It is not always downwards, but the direction of electric field is towards negative plates. So since this is negative charge, the negative charge or the electron will be attracted to the positive plate. Okay, negative going to the positive plate. So the direction will be upwards. Okay, question B, we need to find the magnitude and direction of A. So how to find A? We use equation Q naught E over M. For this question, Q naught is referring to the electron. So what is the magnitude of electron? 1.602 times 10 power of negative 19 or 1.6 times 10 power of negative 19. So we have E and D, so substitute the value. Alright, so the magnitude of the acceleration will be equal to 7.03 times 10 power of 14 meter per second squared, and the direction is upwards or towards the positive plate. Okay, C, calculate the vertical and horizontal components of velocity when it emerges from the space between the plates. So we have Sx, Xy, and U naught, and we know that Vx is equals to Ux equals to U naught, where it is equals to 1.5 times 10 power of 7 meter per second squared. Oops, 1.5 times 10 power of 7 meter per second. And then Vy, how to find Vy? So we can use Vu I. Okay, so Uy equals to 0, but we don't have T. We can find T from the equation. Sx equals to Uxt. Substitute the magnitude of Sx and Ux. We get T equals to 4 nanosecond. So we can find Vy. So Vy will be equals to U0. A, we already find A, that A equals to 7.03 times 10 power 14. And our T is 4 times 10 power of negative nano apa? 9. Okay, negative 9. So we get Vy equals to
Okay, sama tak jawapan kita? Sama. Okay. Right, D, the angle of deflection of electron beam. So since V at the first quadrant, we use tangent theta equals to Vy over Vx. Substitute the value and we get theta equals to 10.57 degree. Okay, that's all for example 1.4.3.
Okay, let's move to the last case, case 3. Okay, we have charge moving parallel to the field. The charge can be positive or negative. Oops, laju sangat. Okay, tengok balik slide tadi. So, positive charge will be attracted to the negative plate. So, a particle with positive charge move with initial velocity U towards the negative plate. So, it can be with a velocity or initially at rest. Okay, so the equation for this charge, it is A equals to QE over M. Okay, this is an electron or negative charge. Okay, it will move towards the positive plate. Since the direction of electric force is upward, same direction and parallel to the direction of motion of particle, the particle is then accelerated in straight line towards negative plate where V is greater than U. So V equals to U plus AT or V squared equals to U squared plus 2AS. And then for displacement, we can use type.
And acceleration equals to QE over M. So where you get this A, it is from Fx equals to MA. Alright. Okay, so bisingkan compound saya. Saya kat unit ni. Alright, okay, kita tengok case 3B, charge moving parallel to the field. Okay, so this one we look at from the side view. So the positive charge will have electrostatic force upwards, and actually we have another one force downwards, which is W. Okay, this is if we look at from side view. So summation of Fy will be equals to MA. So Fe minus W equals to MA, and we will get A equals to QE minus Mg over M. Okay, actually, okay, you can draw W, okay, the direction of W downwards. Okay, sila tambahkan. Okay, look at example 1.4.4. We have a pair of parallel metal plates that are separated by 1 cm with a potential difference applied across them. and then an electron released from rest, so U equals to 0 at the negatively charged plate. It reached the positively charged plate at speed 2 times 10 power of 6 meter per second. Determine V, the potential difference applied across them. So if we draw a body diagram for the electron, we will have Fe upwards and W downwards. So from the Newton's second law, summation of F equals to MA, Fe minus W will be equals to MA. So substitute Fe with QE, okay, and W with mg, E with V over G. So to find V, we need to find the acceleration first. So how to find the acceleration? Since we have value of V and U, we can get A, okay, by substitute the value of V, 2 times 10 power of 6 square divided by 0.01. 0.01 is Sy, okay, the distance between two plates. Okay, it is Sy. So we will get our A equals to berapa? Okay, cuba tekan calculator. And to find V, V is equals to 9.11 times 10 power of negative 31. What is 9.11? This is mass of the electron. Okay, A berapa tadi? Okay, plus 2G. G is 9.81 divided by Q, the charge for electron is 1.602 times 10 power of negative 19 divided by D. D is 0.01. The value of A is 2 times 10 power of 14. So what will be the value of V? V, we will get equals to 11.37 volt. Okay. Okay, so alright class, other than using this equation, who asked, you also can find the potential difference by using the conservation of energy. Okay, so summation of EI equals to summation of E final, where at first the energy initial is the potential energy of the electron, and the final energy is the kinetic energy of the electron, since the electron is moving upwards. So U, what is the formula for electric potential energy? It is equals to QV, and for KE it is equals to half mv squared. So you can find V, okay, rearrange the equation. V will be equals to half times to the mass of electron times to the speed of the electron and divided by the charge of electron. Okay, we will get the same answer where it is equals to 11.37. As you can see, obviously this method or this way is more easier. Okay, so you can use either using VUAS or either using the conservation of energy to find the potential difference.
Okay, next question, we need to find the strength of electric field that exists between two plates. So E equals to V over D. V 11.37, D 0.01. So V will be equals to 1.14 times 10 power of 3 volt per meter.
Scary tak suara yang tadi tu? Mana lagi best? Suara sebenar, suara dilajukan, suara diperlahankan. Okay, so we move to the next question. We need to find the accelerate of electron. Okay, we need to find the acceleration of the electron. So we can use A equals to Q E over M. Substitute all the values. So we get A equals to 2 times 10 power of 14 meter per second squared. And the direction is towards the positive plates. Okay. So lastly, question D. The time taken by the electron to travel from the negatively charged plate to other plate. So we already find this T at the first question A. If you are using the conservation of energy, so you need to find T. So how to find T? We can use equation V equals to U plus AT, because we have V, U at rest, 0, and we have A. So T will be equals to V over A. Substitute the values, we get T equals to 1. 1 ke 2? 1 times 10 power of 14 unit second. Saya saja nak tengok awak dapat detect tak? Salah value of T tu. Okay, so T is equals to 1 times 10 power of negative 8. Jawapan saya ni salah. Kenapa? Sebab tak ada unit. Okay, supposedly you write 1 times 10 power of negative 8 second. And lastly, the exercise, please do it yourself. Okay, to check whether you understand or not this subtopic. So as you know, this is the last subtopic for topic 1. And we will move to the next chapter 2 after this. Alright, bye guys. Assalamualaikum.